Imagine spending 3 hours building this flawless, pristine piece of code with an AI coding assistant.
Right.
And then a colleague just dismantles it in 4 minutes.
Oh, that is the worst feeling.
It really is.
Yeah.
And not because the code was buggy or, the logic was unsound.
Because it was the completely wrong feature.
Exactly. Welcome to the Deep Dive. We're taking a custom-tailored look at how you can maximize the value of AI tools.
Specifically, agentic tools like Claude Code.
Right. But the twist today is that the most important conversation you will ever have with an AI actually happens before you ask it to generate a single line of code.
The paradigm shift here is just profound. I mean, we are exploring a really brilliant piece by tech writer Aaron Rose. It's titled The Secret Life of Claude Code Plan First, Code Second.
Yeah, and what makes this source material so compelling to me is that it totally bypasses the standard dry lists of prompt engineering tricks.
Right. There's no, use these 5 keywords to get better code stuff.
None of that. Rose uses a narrative. It's this story about 2 developers, and it illustrates a masterclass in critical thinking and problem framing.
It targets that really human trap of moving way too fast, which is, something anyone using AI to scale their productivity really needs to understand.
Okay, so let's unpack this. Rose places us in this rather cinematic setting to make his point.
Yeah, it's great.
We're in this grand Victorian library in London. You can picture it, right? Gas lamps flickering outside, the cold wind blowing.
And inside, it's this quiet sanctuary of deep thought.
Exactly. And in this library, we meet Margaret. She is a wise, highly experienced senior software engineer.
And then we have Timothy.
Right, her junior colleague.
Yeah.
Timothy comes in from the cold, bundled up, clutching his notebook. He's projecting this general air of a guy who thinks he is thoroughly, completely prepared.
But as the narrative unfolds, we see that, well, being prepared to do the wrong thing isn't actually being prepared at all.
Yeah, that's a tough pill to swallow.
Timothy sits down with Margaret to explain a recent failure. And the reason this failure stings so badly is precisely because he thought he was leveraging his tools perfectly.
He tells Margaret he spent 3 hours using Claude Code to build a new feature. And his execution, by all technical metrics, it was an absolute triumph.
He provided context, he gave clear prompts, he and the AI iterated through the logic together.
Yeah, the resulting code was clean,
Yeah.
The architecture was rock solid, all the tests passed.
3 hours of just sheer frictionless efficiency.
Then comes the devastating reveal. He took this perfect, pristine code, showed it to a senior colleague, and in about 4 minutes, she completely dismantled the entire effort.
4 minutes.
4 minutes. She pointed out that he had built the wrong thing entirely. Not wrong in its syntax, but fundamentally wrong in its conception.
It's just wild.
It's like spending hours perfectly tuning the engine of a car,
Yeah.
right? Optimizing the fuel intake, checking the spark plugs,
Correct.
only to realize you're on a set of train tracks heading the wrong direction.
Wow.
The execution was perfect, but the conception was fatal. Because what Timothy didn't realize until that teardown was that his solution actually made an invisible adjacent problem significantly worse.
The car and the train tracks is a perfect way to visualize it. When we look at the underlying mechanics of why this happens, Margaret's diagnosis in the text is incredibly sharp.
She really nails it.
She does. Timothy didn't fail because he lacked technical context. He failed because he arrived at the AI prompt with a solution already half-formed in his head.
He preemptively decided what the answer was.
Exactly. And he simply used the AI to dress it up, format it, and compile it.
Which means he never gave the AI the chance to actually help him think.
Right.
Because he was already done thinking. He just wanted a very fast typist.
That's a great way to put it.
And this feels especially dangerous with the specific type of AI Timothy was using. We aren't just talking about a standard chatbot where you copy and paste text.
No. Tools like Claude Code are agentic. They live in your terminal, they read your file system, they execute commands.
The speed at which you can run in the wrong direction is exponentially faster now.
That agentic capability is exactly why this problem is compounding for so many developers. When the tool can execute on your behalf, the friction that used to force you to slow down is completely removed.
It's just gone.
Yeah. And Margaret illustrates this by pointing out a massive illusion that so many of us fall into. We fundamentally misunderstand what a plan actually is.
This part is so eye-opening.
She takes a blank sheet of paper and draws a single horizontal line. On the far left end of the line, she writes the word problem.
Okay.
On the far right end, she writes the word code.
And she notes that almost all developers live their entire professional lives on the far right side. in the code.
Right, or maybe a few experienced ones venture into the middle of that line.
But almost nobody spends time on the far left, in that critical space before the problem is even framed.
Timothy tries to argue that he did have a plan because he knew exactly what he wanted to build.
Of course he did.
Margaret's correction here is the crux of the entire essay. Knowing what you want to build is a destination. It is not a plan.
Oh, that is so good. A destination, not a plan.
A plan is the thinking you do before you begin moving. It's the rigorous questioning you engage in when you are still completely free to change your mind without incurring any cost.
See, I had to push back on this a little bit.
Okay, let's hear it.
Just on behalf of anyone listening who is, nodding along, but also feeling a surge of anxiety, isn't it just basic human cognitive nature to start building?
Oh, absolutely.
Like the second you or I read a JIRA ticket or get an email from a client, our brain involuntarily imagines a solution.
It jumps right to the fix.
Right. Stopping that momentum feels like slamming the brakes on a highway. Isn't that just slowing down our natural progress?
Well, the text actually validates that exact cognitive tension. Margaret acknowledges that the mind desperately wants to move.
It really does.
The moment we understand a problem just well enough to picture a solution, our imagination immediately starts laying bricks. That framing, that initial, often flawed assumption of what the problem actually is, usually happens in haste within the first 5 minutes of reading a request.
Before you've even asked a single clarifying question about why the request exists in the first place.
Precisely the danger. And when we look at how large language models function, we see why this human instinct is so catastrophic.
How so?
An LLM operates by predicting the next most likely token based on the context window you provide.
Right.
So when you show up with a half-formed solution, say you tell it, write a React component to filter this specific data set, you have instantly collapsed the AI's probability space.
You've boxed it in.
Exactly. The model's entire universe of possible responses narrows down to executing your specific architectural choice. You've stripped away its capacity for lateral thinking.
And turned it into an autocomplete for your potentially terrible idea.
Yeah, that's exactly what happens.
So by dictating the solution up front, we're taking this incredibly vast reasoning engine and forcing it into a tiny, predetermined box.
Right. And Margaret has a quote for this in the story.
Oh, something about speed, right?
Speed without direction is not progress. It is a very efficient way of arriving somewhere you did not intend to go.
A very efficient way of arriving somewhere you did not intend to go. That should be framed on every desk.
It really should. And overcoming that requires immense conscious discipline.
So if our human nature forces us to rush toward a solution, and the AI's architecture is perfectly happy to accelerate us into a wall,
Right.
how do we use these tools to pump the brakes?
The source material introduces a brilliant psychological concept here, the gravity of code.
The gravity of code, I like that.
Once code exists, even just a few lines of a prototype, it exerts a gravitational pull on your mind. You immediately start thinking around it, trying to preserve it.
You start rationalizing to yourself and others why it's the correct approach.
Exactly. The sunk cost fallacy takes over.
That sunk cost doesn't just waste time, though. It actively changes your entire perspective. You are no longer an objective problem solver. You become a defense attorney for the code you just wrote.
A defense attorney, yes. And that completely loose warps your subsequent interactions with the AI. You stop asking, is this the right approach?
Right.
And start asking, how do I make this specific approach compile?
Which is the wrong question entirely.
Exactly. That is why Claude Code is an infinitely better thinking partner before the code exists than after.
Because before the code, you are free.
You have no gravity holding you down. You are in a state of pure exploration.
Okay, so if we're sparring with the AI in that gravity-free zone, I imagine we can't just hand it a blank slate and say, think for me.
No, definitely not.
Margaret must have a framework for what we bring to that initial conversation. I mean, we aren't asking for a tutorial, we are asking for a stress test.
You've identified the exact shift in posture. You do not ask the AI to validate your brilliance. You ask it to dismantle your assumptions.
Okay, so what does that look like in practice?
You tell the model, here is the business problem I'm trying to solve. Find the holes. Name the assumptions I'm making.
Point out the edge cases I haven't considered.
Right. Tell me what adjacent systems my proposed logic might accidentally break.
So you are shifting from help me build this feature to help me figure out if this feature is a trap.
Yes.
It's almost like hiring a red team. to attack your idea before you invest a single dollar in manufacturing it.
That's a great analogy. And to facilitate that red team attack, Margaret breaks down a proper plan into 4 mandatory pillars.
4 pillars, okay.
If you don't have these 4 pillars defined before you touch a keyboard, you don't have a plan.
Let's hear them.
The first pillar is the problem statement, but there is a massive constraint here.
What is it?
It must be written out in plain language with absolutely no reference to implementation, architecture, or code.
Oh, man. I can imagine how painful that is for a seasoned developer.
Oh, but hate it.
Your brain immediately wants to talk about API endpoints, state management, database schemas.
Of course.
But Margaret is essentially saying that if you cannot explain the problem without using technical jargon, you do not actually understand the root cause of the user's pain.
You only understand the technical symptoms.
Wow.
The underlying mechanism there is that forcing plain language strips away the technical bias. It forces you to look at the human reality of the system.
Which leads directly into the second pillar, right?
Yeah.
Constraints.
Yes. And the text makes a point to emphasize that we aren't just talking about technical constraints like server capacity or latency limits.
Or third-party dependencies.
Right. We are talking about human constraints.
Human constraints. I really love that concept.
Powerful.
It forces you to ask, who is actually going to have to maintain this monstrous architecture I'm designing?
Who gets paged at 3 a.m. on a holiday if this fragile integration breaks?
Exactly. How does this impact the onboarding time for a new developer joining the team next month? We rarely calculate the human blast radius of our rapid development.
And consider the alternative if you don't map those out. You build something that technically works but destroys team velocity for the next year.
Right. So to prevent that, we move to the third pillar.
The definition of done. This requires specific, unambiguous criteria.
So it cannot be as vague as the feature is pushed to the main branch.
Pushing to production is a beginning, not an end.
Right. What does actual measurable success look like in the real world? How will, without a shadow of a doubt, the thing you built actually resolve the plain language problem you defined in Pillar 1?
Exactly. Which brings us to the fourth and perhaps most crucial pillar.
Okay, what is it?
Risks.
Risks.
What could go wrong? What are the known unknowns?
Margaret points out a fascinating behavioral trend here.
Yeah, I found this part so interesting.
Most professionals, not just software engineers, but people in any industry, skip risk assessment entirely.
Because it feels like pessimism.
Right. It feels like you are raining on the parade and sapping the team's momentum before the project even kicks off. But here's where the text flips the script entirely. Assessing risk isn't pessimism at all. It is the ultimate optimism.
The reasoning behind that is beautiful. Documenting your risks before you start is the only step in the entire software development lifecycle that gives you the power to fix a failure before it actually happens.
It is incredibly optimistic to look at a complex system and say, I believe we have the foresight to identify and mitigate these disasters while there's still just ink on a page.
It's proactive instead of reactive.
So let's make this concrete for a second. Let's imagine a hypothetical prompt using these 4 pillars for Timothy's failed project.
Okay, let's play it out.
Let's say Timothy was asked to build a new caching layer to speed up a user dashboard.
Right.
Instead of jumping into the terminal and telling Claude code to write Redis configuration files, which, collapses the probability space, he steps back.
He opens a blank document.
Right. He writes a plain language problem statement. The dashboard takes 10 seconds to load, frustrating users.
Perfect. No jargon.
Then he lists the human constraints. Our support team is small and can't handle a flood of tickets if data goes missing.
Vital context.
He defines done. Dashboard loads in under 2 seconds with 100% data accuracy. And he lists the risks.
Okay, so then what?
Then he feeds that to the AI and says, act as a cynical, veteran principal engineer. Tear this plan apart.
If he does that, the AI's probability space is wide open to architectural reasoning.
Because it's not just writing a config file anymore.
Exactly. The model looks at the constraints and the risks, and it immediately replies, your proposed caching layer will speed up the load time, but because of the way user sessions are handled, it will likely serve stale, cached data to the wrong users during peak traffic.
Wow.
You are going to cause a massive data privacy breach. The adjacent problem you're creating is worse than the slow load time.
Boom. In 5 minutes of planning, the AI red teams the idea, spots the fatal flaw, and saves Timothy from spending 3 hours building a perfect execution of a disastrous idea.
It's incredible.
Which leads to the ultimate payoff of this entire process. You spend 30 minutes mapping out these 4 pillars, and you avoid hours of rework. But the ROI goes even deeper than that, doesn't it?
Oh, the ROI reaches the very foundation of why we do this work. Margaret highlights what is perhaps the most uncomfortable but absolutely most valuable discovery a rigorous plan can produce.
What's that?
Sometimes when you map out the plain language problem and the constraints, you realize the problem itself is wrong.
Wait, not that your technical approach is wrong, but the actual task you were handed by leadership is flawed.
That is the upstream catch.
Wow.
You might discover that a feature requirement you were handed was based on a complete misunderstanding of user behavior by someone, 3 levels above you in product management.
Or you realize that the shiny new tool you've been asked to integrate is just a Band-Aid.
Exactly. Treating a symptom instead of addressing a massive, rotting architectural issue at the core of the platform.
But to catch that upstream error, you have to do the planning work first. You can't just look at a Jira ticket, glance at the title, and say, "This is wrong."
No, you'd be laughed out of the room.
You have to earn the right to push back.
Earning the right to push back is the key metric of a senior professional. You cannot credibly question a requirement that you haven't rigorously examined.
Right.
But if you walk into a meeting not with a defensive attitude about code you've already sunk hours into, but with a thoughtful, AI, stress-tested, 4-pillar plan that logically highlights a fundamental flaw in the business request.
Leadership is going to take you seriously.
They have to.
It totally shifts your identity within the company. The plan is the dividing line.
How so?
It is the exact boundary that separates the developer who merely builds things from the developer who actually solves problems.
I love that.
Because anyone can build something if you give them a blueprint and an AI coding assistant. But figuring out if the blueprint is even pointing at the right piece of land, that is true problem solving.
And that separation brings us back to the psychological cost we discussed at the beginning of the story.
Right, poor Timothy.
Margaret asks Timothy what 30 minutes of planning would have cost him compared to the 3 hours of perfectly executed rework. And Timothy realizes that the true tragedy of his failure wasn't the lost time.
Time can be recovered.
The tragedy was the total deflation of his professional confidence.
He went in with absolute, unwavering certainty, only to find out his certainty was entirely hollow.
Because he hadn't done the foundational thinking. Doing this planning work using an AI to ruthlessly spar with your ideas before you commit them to reality gives you 2 distinct, priceless gifts.
Clarity and confidence.
Exactly. It gives you absolute clarity before you start typing, and it gives you unwavering confidence after you finish compiling.
Because if an advanced reasoning engine tries to poke holes in your 4-pillar plan and can't find any structural flaws, you trust the subsequent work so much more.
You step out of that Victorian library, back out into the cold wind, knowing your foundation is completely solid.
So to synthesize all of this for you, whether you are using agentic AI to code a complex software application, structuring a massive corporate merger, or, I don't know, just organizing a chaotic home renovation.
Right. It applies anywhere.
The most vital, high-leverage work happens before the building begins. You have to resist the gravitational pull of the immediate solution.
And that resistance is only going to become more critical. Which leads to a final thought I want to leave you with today.
Okay, let's hear it.
We've talked a lot about the danger of an individual moving too fast with a half-formed solution. But take a moment to consider the scale of where technology is heading.
It's moving fast.
We are moving into an era of AI agents communicating with other AI agents. Systems autonomously requesting resources, writing code, and deploying infrastructure across entire enterprise networks.
A cascade of light-speed execution.
Exactly, a cascade.
Yeah.
If we as the human operators do not inject this rigorous 4-pillar planning phase before the chain starts, we are no longer just making individual mistakes.
We're scaling them.
We are risking automated compounding failures at light speed, where an AI executes a flawed premise, passes it to another AI, and scales an invisible problem across an entire ecosystem before human even checks the logs.
Wow.
Think about the biggest project or tasks sitting on your desk right now. You probably already have a solution half-formed in your head. But ask yourself, if you executed that solution perfectly right now, what is the invisible adjacent problem you are about to make significantly worse?
Such a vital perspective. The faster the machine runs, the more important it is that the human points it in the right direction.
The speed of the tools makes the slowness of our planning the most valuable asset we have.
Get off the train tracks, step back into the library, and figure out your destination before you worry about your velocity. Thanks for joining us for this deep dive into the secret life of planning. Keep questioning the frame, and we will catch you next time.